Welcome back. Today we're going to be working on volume of complex figures. Our content objective is students will be able to find the volume of complex figures. Our language objective is students will be able to find the volume of complex figures. And last but not least, why am I learning this? Well, it's important for real world problems like determining how much bird seed will fit in a bird feeder. Okay, so first things first, let's go ahead and take a look at what we have here. It says, find the volume of the complex figure, round to the nearest tenth. So first, what I want to do is I want you to recognize the two different shapes that make up this complex figure. The first thing I notice is a hemisphere. Okay, hemisphere just means half of a sphere. And I also notice that there is a rectangular prism. Okay, so once I have that, what I'm going to go ahead and do is find the volume of these different shapes. So first things first, to find the volume of this hemisphere, I need to first find the volume of a sphere, which is 4/3 pi r cubed. Now, one thing that I also want you to consider, since it's only half of it, what I'm going to go ahead and do is take half of the volume. Well, there's two ways to do that. You can totally divide this entire thing by 2, or you can multiply by 1/2. Okay, I think it's going to be easier for most of you to go ahead and multiply by 1/2. Okay, please understand that's the same thing as dividing this entire thing by 2. So now that I have done that, all I need to do is replace the radius. Okay, so what's the radius? Well, if we take a look here, we're going to have to look that this entire length is 12, which means this diameter is 12. But since we're interested in finding the radius, since this is 12, I'm going to go ahead and say that the radius is 6. So I'm going to go ahead and say the volume equals 4/3 pi. I'm going to go ahead and replace the radius with a 6 because that's what's half of 12. Cube that number and multiply by 1/2. Now that I have that, I'm going to go ahead and simplify. We have 4/3 times, let's go ahead and just put pi over 1 to make that part of a fraction, times 6 times 6 times 6 is 216. So I'm going to put 216 over 1 times 1/2. Now, what we're going to do is go ahead and cross-reduce whenever possible, because whenever you can, it's going to save us some time. I'm going to go ahead and see that 4 and 2 have a 2 in common, so 4 becomes a 2, because 4 divided by 2 is 2. 2 divided by 2 is 1. Can 3 go into 216? Well, remember the quick way to test is to add up all the digits. 2 plus 1 is 3, plus 6 is 9. So can 3 go into 9? Absolutely. So it also goes into 216. So 3 divided by 3 is 1. 216 divided by 3 is going to give me 72. So now that I have that, I'm going to go ahead and say the volume is, multiplying straight across, we have 2 times pi times 72 times 1, which is going to give us 144 pi. Now our denominator is 1 times 1 times 1 times 1, which is just 1. So I'm going to go ahead and leave this. So the volume of this hemisphere right here is 144 pi. Now what I'm going to have to do is find the volume of this prism. So that's this right here. So the volume of a prism is basically the area of the base, which we're going to use a capital B to represent that. That is different from a regular lowercase b. Okay, because the lowercase b stands for base, capital B stands for the area of the base, times the altitude, which is just another fancy word for height. Okay, so here we're going to say the volume is the area of the base. Well, here the base, there's two different bases that we can look at. I'm going to go ahead and look at the base that's below here that we can't kind of see. Okay, so here the base is 12 by 14. It's this right here. So I'm going to go ahead and put the volume equals this rectangle right here, which is 12 by 14. And then how tall is it? Well, the altitude is 12 centimeters. So I'm going to go ahead and multiply by 12. So here the volume is 12 times 14 times 12. I am permitting you to use a calculator, so let's just go ahead and plug that in. That is going to give me 2016. Now we're not done because now we found the volume of this rectangular prism is 2016, and we also know that the volume of the hemisphere is 144 pi. So to add up the total volume, I'm going to go ahead and put that it's 144 pi plus 2016. So I'm going to go ahead and punch it into the calculator, 144 times pi, which we're going to use 3.14 to approximate that. Once I find the product of that, I'm going to go ahead and add to 2016. So I'm going to go ahead and say that the final volume is 2,468.16. However, the instructions does ask us to round to the nearest tenth. So here, the 6 is going to determine whether this one is going to stay the same or be rounded up. Since 6 is more than 5, we're going to go ahead and round up and say that the final answer is the volume equals 2,468.2, and this is, since it's centimeters, I'm going to put centimeters cubed. So all that we're really doing is breaking up the complex figures into shapes that we know that we can find the actual volume of, and then we're going to go ahead and add them together to find the actual volume. So since this, we had to approximate pi as 3.14, it is technically an approximation and not an exact answer. Okay, so now let's go ahead and move on to the next one. Now taking a look at this one here, it says find the volume of the complex figure round to the nearest tenth. So first things first, what we're going to do is go ahead and identify the two shapes that we see. I see a hemisphere, okay, which again is just half a sphere. And then I also see a cylinder right here. So first, let's go ahead and start with the hemisphere. We're going to first start with what the volume of an actual sphere is. So we're going to say volume equals 4/3 pi r cubed. Last time I showed you how to do half of it by multiplying it by 1/2. The other option is to also just divide the entire thing by 2. So I do want to show you both. You do whatever you feel more comfortable with. So now that I've set it up, I'm going to go ahead and find what I need, which is going to be the radius. Here, it doesn't tell us directly what the radius is, but I do know that it's the same as this cylinder here. So if the cylinder down here is marked that the radius is 3, the radius of the hemisphere should also be 3 centimeters. So here we're going to put volume equals 4/3 pi. The radius is 3, so let's go ahead and put 3 cubed divided by 2. Now, one thing that I didn't do on the previous example was this step right here. I actually would prefer you to write it like this, where we put 4/3 pi times 3 cubed. Let's write it out. 3 times 3 times 3, and then divide by 2. Why would we want to do that? Because by doing that, we can actually see that the 3's cancel out. It just makes it a little bit easier. It's not wrong to do it the previous way, but I just wanted to show you the other option. So here I'm left with volume equals 4 pi times 3 times 3, so that's 9. So 9 times 4 is 36. I'm going to be left with 36 pi over 2. Well, these can, we both have a 2 that we can go ahead and cross cancel. So this is going to leave us with 18 over 1. So the volume of this hemisphere is 18 pi. So I'm going to go ahead and mark this as 18 pi. So we're halfway done. Now we're going to go ahead and find the volume of the cylinder. So now we're going to go ahead and write down the formula. It's always a good habit to practice writing it down. It's going to be a little bit easier for you to commit to memory doing it that way. So here, the volume of a cylinder is, you can kind of follow the same thing as the prism. It's the area of the base. The base is a circle. So you're going to go ahead and do pi r squared times the altitude or height. Okay, so let's go ahead and plug in our numbers. The volume equals pi r. Well, the radius is 3, so I'm going to put 3 squared times the height, which is 9. So that leaves me with the volume is, well, 3 times 3 is 9. 9 times 9 is 81, so we have 81 pi. So here the cylinder is 81 pi. So the final volume is going to be the hemisphere, which is 18 pi, plus the cylinder, which is 81 pi, which is going to leave me with a total of 99 pi. Now here's where I can go ahead and plug it into the calculator. So let's go ahead and do 99 times 3.14. Notice we are approximating pi by using 3.14. So let's go ahead and plug that into the calculator. We have 99 times 3.14, which gives us 310 and 86 hundredths. Now, real quick, it does ask us to round to nearest tenth. So looking here, the 6, will it make the 8 to go up or stay the same? Since it's larger than 5, we're going to go ahead and say that the volume is 310 and 9/10 because the 6 rounded the 8 up. It is in centimeters, so I'm going to put centimeters cubed. For number 3, let's go ahead and find the volume of this complex figure. And again, we're going to be rounding to the nearest tenth. So here, what I notice is an entire sphere. Now, why would you say that? Well, I see half of it here and another half here. So if you wanted to, you can combine that and make it in an entire sphere. So that's why it's not a hemisphere, it's a complete square, a complete sphere, because with both of them combined, it would make one total sphere. The other thing I notice is that there is another cylinder. So let's go ahead and piece these together to find the volume of the complex figure. The volume of the sphere is 4/3 pi r cubed. So let's go ahead and plug in our values. We're going to write 4/3 pi, instead of r, let's go ahead and find the radius. Well, here for the sphere, it should match the radius of the cylinder since they are perfectly aligned. So it's going to also be 9 inches. So I'll go ahead and put 9 cubed. So here, it would be very helpful for you to actually write out the 9s. And let me explain why in a second. I'm going to go ahead and put 9 times 9 times 9. This is technically over 1. Now, why was that helpful? Because then I can see here that they do cross cancel. Both the 3 and 9 have a 3 in common, so 3 divided by 3 is 1, 9 divided by 3 is 3. So the volume is 4 times 3, which is 12, and 9 times 9 is 81, so 12 times 81. Let's go ahead and plug it into a calculator. 12 times 81 is 972. Now, real quick, a very common error that I notice a lot of students commit is they forget about pi. So some students would stop here. So be very careful. There's still a pi. So let's write that in. So of these two spheres, I'm going to go ahead and say that the volume is 972. We found the volume of sphere. Now let's go ahead and concentrate on the cylinder. The volume of a cylinder is the area of the base. The base is a circle, so we're going to do pi r squared, that's the area of a circle, times the height. So let's go ahead and plug in the values. We're going to put pi. The radius is 9 inches. Whoops, we don't need to put inches in there. So we'll put 9 squared times height, which is 11. So now we have volume equals 9 times 9 is 81. Times 11, let's go ahead and plug that into a calculator. We have 81 times 11, which gives us 891 pi. So now that we have the volume of the sphere and the volume of the cylinder, we can go ahead and add them up together. 972 pi plus 891 pi is going to give us a total of, just to save us some time, let's go ahead and add those together. 972 plus 891, which is going to give us 1,863. And again, don't forget pi. Again, since we're allowed to use calculators, let's go ahead and plug that in, 1,863. Instead of pi, let's go ahead and put 3.14. Plugging that into a calculator, we're going to put 1,863 times 3.14. which is going to give us 5,849 and 82 hundredths. We're rounding to the nearest tenth. Is this 2 going to make it go up or stay the same? Since 2 is less than 5, we are going to stay at the same. So we're going to say the volume is 5,849 and 8/10 inches cubed. And that would be our answer. Moving on to our very last example, we're going to go ahead and find the volume of, again, the complex figure, and we're going to be asked to round to the nearest tenth. So first, let's recognize what 2 shapes we see. Number 1, I see a cone. Number 2, I see a cylinder. So let's go ahead and write down the formulas and just get down to finding the volume of this complex figure. So the volume of a cone is going to be V equals 1/3 pi r squared. So here I'm interested in finding the radius, times height, almost forgot. So I'm interested in finding the radius and the height of the cone. So here it doesn't tell us what the radius is, however, it does tell us the diameter of the cylinder. So from there, if I know this diameter is 24, I can then make the assumption that the radius must be half of that, which is 12 feet. So let's go ahead and plug that in. We have volume equals 1/3 pi radius, which is 12 squared, times the height. Well, the height is marked here as 16 feet, so let's write 16. So now let's go ahead and expand this out, and the main reason why we're doing that is just to check to see if we can cross cancel. I'm going to go ahead and put pi over 1. And the reason why I'm showing you this is some students tend to put pi in the denominator, which is wrong, so be very careful. I'm going to write 12 squared out as an extended product and put that over 1 as well, and times 16 over 1. Now, why did I do this? Because I want to check to see if I can cross cancel the 3 with any of my values, which I can. 3 can be reduced with 12. Both have a 3 in common, so 3 divided by 3 is 1. 12 divided by 3 is 4. So the volume is 1 times pi times 4 times 12 times 16. Let's go ahead and save us some time. Put that in a calculator. 4 times 12 times 16 is going to give us 768. And again, don't forget pi. Our denominator is just 1, so there's no point in leaving that. So that's the volume of the cone. Let's go ahead and draw that in, 768 pi. Now that we found the volume of the cone, let's go ahead and find the volume of the cylinder. So the cylinder is volume equals the area of the base, which is a circle. So it's pi r squared times the height. So here I'm interested in finding what the radius and the height is. Since the diameter of the cylinder is 24, again, we can go ahead and make the assumption that the radius is 12 feet. So I'm going to put pi times 12 squared times the height here. The height is marked as 9 feet. So all we're going to have to do is square 12. I do know that that's 144, so I'm just going to put 144 times 9, which is going to give me 1,296 pi. So now that I also figured out the volume of the cylinder as 1,296 pi, we can go ahead and combine everything together and say the volume, let's try that again. The volume is the area of the cone, which is 768 pi, plus the volume of the cylinder, which we got as 1,296 pi. So to find the total volume, I'm just going to go ahead and add them together since they are like terms. We're going to do 768 plus 1,296, which is going to give us with a total of 2,064 pi, but we're not done. We're going to go ahead and replace pi with 3.14, which again is just an approximation of pi because pi is irrational and it goes on forever. So here, let's go ahead and multiply 2,064 by 3.14. which is going to give us 6,480.96. Since we are asked to round to nearest tenth, let's go ahead and check. Is the 6 going to make the 9 go up or stay the same? 6 is greater than 5, so we're going to go ahead and kick it up a notch and add 1. Notice when you add 1 to 9, it is going to make it greater by 1, so it actually changes the volume to 6,481.0. And we're just going to go ahead and put feet cubed. So that is our final answer. So thank you so much for tuning in. And as always, until next time, bye.